We are going to talk about a typical question, classical question called graph valid tree. So a tree is kind of a type of graph that nodes have n nodes labeling from 0 to n minus 1 and then with edges from AI to BI. And there shouldn't be any self loop, so AI is not equal to BI as the condition at the bottom indicate. And also return true if the edges of the given graph make a valid tree, return false otherwise. So here, given a graph constructing with nodes and edges, we first need to check if the number of edges in the tree should be equal to the number of nodes minus 1. That is the first condition. The second condition for a valid tree is it shouldn't have any cycle in it. So in this case, even though we have 5 nodes and we have 4 edges, there is a cycle inside the edge. So the cycle condition is does not satisfy. The third condition is it shouldn't be connected. So all the nodes should be connected, which means from every node we can reach other nodes in the tree. Therefore, in this case, although we have 1, 2, 3, 4, 5, 6 nodes and we have 5 edges, they are disconnected. So we also need to check this disconnected condition is satisfied for the invalid tree. So here we divided the problem into 3 steps. The first step is check the number of edges equal to node minus 1. The second step is check the cycle. Check if we have cycle given a graph. The third condition is we check if they are all connected for a given graph. So these 2 and 3 steps can be combined together when we do the depth first search algorithm. So here I want to use the depth first search method to solve this question, and you can also use DFS or union find to solve this question. So here the first condition is to check the number of nodes equals minus 1 equal to the number of edges, right? So here this condition. So if length of edges not equal to the number of nodes minus 1, then we directly return false, right? And then after that, we check if there's any cycle in it, which means the cycle checking condition, right? So here, checking the cycle. So how to check the cycle? We need to use the DFS method. And then the third part is during this cycle checking condition, we also need a visited set to keep track of all the nodes that has been visited, such that once there's already a node in the visited set, that means a cycle is detected, we will return false immediately, right? And then the third condition is the number of connected condition. So after we finish all the program, the nodes in the visited should be the number of n. That means we have visited all the nodes, right? So if there is any disconnected component, the nodes in the visited should be less than n. So this condition will break. So here, if we need to check the length of the visited is equal to n finally. So after here, we also need to, because a tree is all connected nodes, so no matter where we start, we can always visit all the nodes inside the tree. So it doesn't matter which node we start, but for convenience, here I will start from 0. So here detect, I will start from 0, right? So if I detect any cycle starting from 0, that means we can return false, right? Otherwise, we will check the last condition. Okay, so regarding this DFS, this detecting circle procedure, I will declare in another function called def detect the cycle, which is n, right? So here I will check if here I will add the n to the visited first, right? So visited.add this node, and for all the neighbor for this node n, I need to check if the neighbor has certain cycle. So it is a recursive way. So also given the edges, we need to construct a graph first, right? So after this checking condition, if the number of edges is now to n minus 1, we will construct the graph called graph equal to collections. So default east, okay, and then for ij in graph in edges, then graph I add all the j to the graph i's neighbor, append j. Since it is a undirected graph, we also add all the neighbor of j to the list of j, right? Here we can construct a graph. And then after we constructing the graph, here I visited nodes, visited set at a number of node. Then for all the neighbors of the node, of the current node, I will check if that neighbor has been visited or not. Then if it hasn't been visited, I will check if there is certain cycle starting from its neighbor. So I will recursively call this function, return true, right? Otherwise, return false. Okay, so when I call the function detect cycle 0, I will return false if there's any cycle in it. So I first run the code. Okay, detect. Let's see. Oh, there should be a intent. Okay, run the code. Collections. Default big. Okay, default. Okay, the test case passed. Okay, run faster than 97%. So that's it. That's this question. And also we have also a very similar question called number of connected components in a directed graph. So in this case, you can just I think copy the code from the question 261 to this part. So basically, you can copy the code here. right? So here, the detecting cycle part is always is the same, and then this one you don't need to check. The constructing graph part is also the same. The visited part is also the same, but for the detecting cycle part for I in range n, we need to check if I not in visited, right? So we will use a count to keep record of how many cycles we have found so far. So count equals to 0, and we will add count by 1, right? Return count, right? And here we will call this detect cycle function for I. And the condition here, if it is we found the cycle, we return true, otherwise we return false. So if it's not so here we just return true if we find a cycle, or otherwise we couldn't find a cycle. So as long as it has been visited, that means we already count how many cycles we found so far. So let's see. Okay. Okay, so basically these two problems are the same kind of problem. So you can compare and try to borrow the code from previous question to this one immediately. So thank you for watching.